So, Ms. Avantika, Bohr model for hydrogen and hydrogen-like atoms. So, see, one thing that we need to understand, and we need to understand and accept, and be aware of, is that we are doing this in chemistry, class 11th. Again, we will doing this. We will be doing the same topic in class 12th, physics, and those would be the end chapters, part of modern physics. So, why I am trying to tell you in this beginning of this lecture is that this particular model is understood in detail and is understood well by the time you reach this stage. When you are in class 12th physics, you are end of the syllabus, because a lot of things which would be discussed in this particular topic, a class 11th student is not much familiar with and is not much aware of. So one thing, am I clear?
Yeah.
So basically the problem that you will face is that frankly, you won't be able to understand 100% of the concepts which are being discussed. Even if you are able to understand, say, 60%, 70% of the concepts, it is absolutely fine, and rest of the 30-40% you will have to cram. Am I clear?
Yeah.
So don't get frustrated about topics that I will be discussing which you haven't heard before. It is absolutely okay, because anyways, this topic will come again in class 12 physics. Right now, I'll be just rushing through the topic, just trying to tell you which are the important concepts that you should be aware of. And more than half of the lecture, even if you are able to understand more than half the lecture, it's a good achievement. Are we clear?
Yeah.
So from this chapter, if you want to score well, maybe you'll have to cram a lot of things, even if you don't understand them. I can't be more blunt than this. Are we clear?
Yeah.
Okay. Now a bit of background. So if you want to understand what happened before Bohr's model, you know, or you might have known that before, Bohr's model, there was Thomson model, Rutherford model. So those scientists are usually taught in class 9th, 10th. But if you want to review, can you see this lecture? Can you see this YouTube lecture, Thomson model, Rutherford model?
Yeah.
So you can have a look at this. This is at a very elementary level, class 8th level. So this is what happened before Bohr. And this is the other end of the spectrum. If you want to really understand what Bohr model is all about, you'll have to look at this class 12th physics lecture. Are we okay?
Yeah.
But between these two spectrums, we are somewhere in between. Are we clear where we are?
Okay. Yeah.
So, our expectations should be very clear. Please don't assume that you will be able to understand whole of this structure of atom till the time lot of your physics concepts are in place. And of course, a class 11 student faces that difficulty. It is absolutely fine. So don't get frustrated. Needlessly frustrated. That is what I'm trying to say. Are we clear?
Yeah.
Okay. So let us start with this introduction. See, there are few things. There are 3 questions which will be asked, which have a good probability of being asked. One would be the postulate of Bohr's model of atom. Yeah. The second would be a numerical based on the formulas which are discussed. The important formula would be this formula. This would be the important formula. And the third, important question that they asked is defects in the Bohr's model. Are we clear? One thing.
Yeah. Yeah.
There is a 4th thing that you need to understand and need to cram. The name of these series. We'll discuss these series. Don't worry. Lyman, Balmer, Paschen, bracket, P fund. It is called fund, but I call it P fund so that I remember it correctly. Are we clear?
Yeah.
So these are the 5 things. Either we understand or we cram. It is as clear as that. No other question is asked. So let us first look at Mr. Bohr. Mr. Bohr's model is actually the model which is taught in class 10th. So here we are looking at the postulates. So what Mr. Bohr was postulating was, see, before this, the root cause analysis was when they used to look at these. There is a bit of background. I don't want to go in much of the details, but whenever they used to look at these spectrums of gases, they used to see different colors. So in very simple terms, let me look at let me take let us assume neon gas. So in this glass tube, neon gas is there. Are we clear, Avantika?
Yeah.
You would have seen those neon lights in Hollywood movies. Have you ever seen?
Yeah.
In bars,
Yeah.
etc. So those neon lights. So let us assume that this is a very rough diagram, so you'll have to excuse me. But let us assume that we pass electricity through this neon gas. When I pass electricity through neon gas, it emits a particular color. If I take any other gas, it emits a certain color. So the problems that these scientists were facing was they couldn't give the answer why a particular color only is emitted. Are we clear one thing?
Yeah.
So let us assume that neon emits purple color. The problem that they were facing is why neon emits purple color. Are we clear? One thing.
Yeah.
So different gases they used to take, and let us assume we pass electric discharge through it, and the gas will emit only a particular color as per. So basically, the things were so stark, in very general terms, the things were so stark that if I see a certain gas emitting purple color, I was sure that it was neon. Are we clear?
Yeah.
Is it making sense?
Yeah.
So this is what Mr. Bohr was trying to explain. So what he said was, so this was the first simple postulate that he said was that boss ऐसा है कि the electrons they revolve around the nucleus in certain permitted circular orbits only. Are we clear?
Yeah.
And he called them the energy levels or energy states. What it says is that if there is an electron, if it has a particular energy, it can go only to a certain orbit. It can't go to any orbit. Are we clear?
Yeah.
It is like, do you know in Bombay there is something called floor rise? So as per the no, as the if there is a 50 floor building, do you know that the 48, 49, 50th floor are usually expensive than the first and second floor? Do you know that?
Yeah. Yeah.
Yeah.
Yeah.
So that is what Mr. Bohr was trying to say, that in an atom also the same thing happens, that there are orbits. One thing that you need to understand is they were circular orbits, and the second thing is that if an electron is in a certain orbit, it can be only in that particular orbit if it has the energy which is required for it to be in that orbit. Are we clear, Avantika?
Yeah.
So what I'm trying to say is, in simple terms, what I'm trying to say is that if there is an electron in this orbit and if there is an electron in this orbit would have higher energy than this orbit. Are we clear?
Yeah.
So if I have an electron here and I want to take this electron to this higher orbit, I'll have to give some energy to this particular electron. Avantika, are we clear?
Yeah.
See, one of the easiest way, what I have found is one of the easiest way to understand this particular topic is one of the easiest way of understanding this particular topic is that imagine a tree. Can you imagine a tree?
Yeah.
So this tree has different branches, and you are standing here, Miss Avantika,
Hmm.
and this is the nucleus. This is the easiest way of understanding this. So you are standing here. This would be your ground state. Are we clear?
Yeah.
Now you can go to the first branch. Actually, this ground state. So for example, let us take the example. Let me try to give a symmetrical understanding vis-a-vis hydrogen also. So for hydrogen, this electron would be in the ground state. So this shell n is equal to 1 is the ground state. Avantika, are we clear?
Yeah.
Now, of course, if you have to go to the this first branch, if this is the ground state, for me this would be the n is equal to 2 would be this shell. Avantika, is it making clear? Is it making sense?
Yeah.
Then this would be n is equal to 3. This would be n is equal to 4. Are we clear, Avantika?
Yeah.
So from ground state to this state, if I have to go, then you will be required to give energy. Otherwise, how can you go? Are we clear?
Hmm. Yeah.
So from second to third, if you have to go, again you'll have to go give some energy. Are we clear?
Yeah.
And so on. Are we clear?
Yeah.
Now, let us assume you reach here in space. Now, space, or let us, for a better understanding, let us call this infinity. Are we clear, Avantika?
Yeah.
Now, once you reach space or infinity, do you have any relation with Earth? Do you have any relation? So, for example, let me assume that you reach Pluto. Once you are in
Hmm.
Pluto, once you are in Pluto, is Earth attracting you as much as it was when you are right now on Earth?
No.
So, from energy point of view, we'll say that from an energy point of view, you guys don't have much of a relation between you two. Am I clear?
Yeah.
So, what we'll say is that the energy between you and Earth, when the distance is infinity, the energy between you two is zero. Are we clear, Avantika? Miss Avantika, are we clear?
Yeah.
Now, there is a small thing that you need to understand. If this energy is zero, what I know is just try to imagine this. This will make sense in next 2 minutes. This energy is zero. But I know that this energy, the energy that I have at this distance is the energy that I have at this distance is more than the energy that I have at this distance. The energy here is more. The energy here is more. Is it making sense or not?
Yeah.
वैसे भी समझ आ रहा नहीं आ रहा? You'll have to understand both these concepts together. One is that from going here to here, from going here to here, from going here to here, you will have to increase your energy. Are we clear?
Yeah.
But at infinite distance, the energy is zero. Are we clear?
Yeah.
This is, the first time we hear it, it is a bit of a paradox. But let me write something and then it will make sense. So if I write this as minus 10, minus 8, minus, 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 and so on. Of course, here it will be zero. Is it making sense, Avantika?
Yeah.
So now let me repeat it again. As you go far from the nucleus, your energy increases. But at infinity, your energy is zero. Are we clear?
Yeah.
So the only way I can, mathematically write this is that energy state 1, energy state 2, energy state 3, all of the energy states are negative. And as I start going from orbit 1 to orbit 2 to orbit 3 to orbit 4, I'm going from minus 10, minus 9, minus 8, minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1. And when it is zero, basically I'm at infinity. The electron and the nucleus have no relation with each other. Are we clear?
Yeah.
I understand that this concept is a bit difficult to understand, but there is no other way. You'll have to understand
Yeah.
this. Yeah.
Yeah.
So I am going ahead with the assumption that you are clear. Yeah.
Yeah. Yeah.
Unfortunately, right now I can't make this particular concept more easy than this. At this point, this is the easiest way I can present this topic to you. Are we clear? Maybe 6 months down the line, I'll have a better example, but right now I have this example only. Are we clear?
Yeah.
So that is why whenever you will look at this energy of the electron, you'll always see a negative sign here. Are we clear?
Yeah.
So this energy will always have a negative. And this energy, what is this energy? Let us spend just 2 minutes understanding this concept. I think you will understand. See, what I'll suggest is just consider a hydrogen atom now. And that is what
Yeah.
Bohr also do. So Bohr also took hydrogen atom because there was a single proton and single electron. So this model, one of the disadvantages of this model is doesn't work with many electron atoms. Are we clear, Avantika?
Yeah.
भाई बोहर ने क्या किया? In very simple terms, बोहर ने क्या किया? He was able to explain the hydrogen spectrum. उसने जो हाइड्रोजन का कलर आ रहा था ना, he was able to explain that कि भाई इस वजह से ये कलर आ रहा है. Are we clear, Avantika?
Yeah.
At that time, that was the question कि ये कैसे हो रहा है? And he said this is a model which explains this. Of course, when this model was there, फिर scientists started asking more questions, and then Bohr said, "भाई अब तुम देख लो." Is it making sense?
Yeah.
So then the rest of the scientists came: Heisenberg, Schrodinger, de Broglie. So all this came. Very young chaps, 20, 23, 24, 25 chaps, 25-year-old chaps. So Bohr took the story to a certain level, and the model was good enough because till date, जो भी हम जैसे अब class 10th में the model that we study, that 2881, 2882 is basically based on Bohr's model only.
Yes.
Are we clear till here?
Yeah.
So now let us try to understand this energy concept a bit in detail. Not much in detail, but whatever detail that we require. So I have a hydrogen atom where this is a proton, single proton, and this is an electron. Are we clear?
Yeah.
Just do a simple thought experiment. Just a simple thought experiment. If you want to take this electron away from the proton, will the proton let you take this electron away? Will it allow? Will you be easily able to take this electron away from this proton? Miss Avantika.
Yeah.
Why easily? You are with your mother and I come to your home and say, Avantika, let's go for a ride. Will you come easily?
No.
No ना. तो अभी वो इलेक्ट्रॉन और प्रोटॉन में भाई कुछ तो अट्रैक्शन है ना. So any random guy will ask the electron, चल घूम के आए. Will the proton allow?
No.
Is it making sense?
Yeah.
Okay. Now let me take a bad example, but there is no other way of explaining the things. So now Ritik Roshan is in your locality, yeah, and you tell your mom. Let us assume you don't even tell your mom. Your friend tells you on WhatsApp that Ritik Roshan is there in the locality. Yeah, will you rush out to meet Ritik Roshan or see Ritik Roshan?
According to the situation, yeah.
Yeah, of course. So I'll give you a small example. So for example, a few years back, we came to know that Christopher Nolan was here in IMAX. Do you know Christopher Nolan?
Yeah, I've heard about him, but I don't remember.
So he's a big Hollywood director. He's a big Hollywood director. Yeah.
Okay.
So first we were shocked, but then we checked and then we came to know that yes, he was there. So all three of us just rushed. And there was a guy who was offering 4,000 rupees per seat for being in the same hall that Christopher Nolan was. So he was charging us, I think, 10,000 or 12,000 rupees. This actually happened.
Oh.
The point that I'm trying to make is it is not easy to take away this electron. You'll have to provide some energy. Are we clear?
Yeah.
Now see if it makes sense to you or not. If this system, this proton-electron system, has an energy of minus 5 joules, then if you give an energy of 5 joule, the energy of the system will become 0 joule. And what we know by 0 joule is that the electron will go to infinity. Are we clear?
Yeah.
This is what is called the ionization energy that you had studied in class 10th or what you study in periodic table. Are we clear?
Yeah.
Ionization energy, I'll repeat. So ionization energy, try to listen to this carefully. Ionization energy of a hydrogen atom would be the energy required to take away that one electron from hydrogen atom when hydrogen is in gaseous state. Are we clear?
Yeah.
So if I come to your home and I call you, Avantika, let's go for a ride. You don't come for a ride because you have to ask your mother. But if I give a sufficient amount of energy, so I can take you for a ride. So let us take example of Raman. So Ravan provided a certain amount of energy and took Sita away. Are we clear, Avantika?
Yeah.
So I'm trying to make things as easy for you as is possible. So the point that I'm trying to make is, so for example, Shivang is there. So Shivang is now, he will ask me, Papa, मैं ये कर लूँ, Papa, मैं वो कर लूँ. But 2 years down the line, he has a girlfriend. Okay? Then one day I come to know that Shivang has run away with that girlfriend. Is it making sense, Avantika?
Yeah.
So now, in that stage, when he runs away, then Shivang and me have zero energy. Are we clear?
Yeah.
Because then Shivang has in Shivang and me system, the energy is zero now because he has gone to infinity. Are we clear?
Yeah.
Okay. So I hope these numbers of examples should be enough. So this is what Bohr was trying to say कि आप जैसे जैसे you go away from the orbit, your energy will increase, which also implies that if you have to take the electron to the higher shells, you'll have to provide energy. Are we clear or not?
Yeah.
Yeah. Okay. Now, this is what he is trying to say. So whatever we have discussed now is this is what he is trying to say in his postulate 2. While moving in a particular energy level or energy state, electron neither loses or gains energy. The energy of electron in a particular energy state always remain fixed or stationary. तो जब तक वो उस अपनी ऑर्बिट में है तब तक उसकी एनर्जी स्टेशनरी रहने वाली है. आर वी क्लियर?
Yeah.
So what I'm trying to say is कि if it is in orbit 4, तो orbit 4 में जितनी एनर्जी चाहिए उतनी ही एनर्जी होनी चाहिए. Are we clear?
Yeah.
Okay. Now I'll skip 3, but I'll come to 4 because now you'll understand this 4. On absorption of energy from an external source, an electron may jump from a lower energy to a higher energy. In coming back from higher energy to lower energy, the electron emits energy. Let us try to understand this postulate 4. So अगर electron lower orbit में है and if it wants to go to the higher orbit, energy would be, Mr. Shiva, energy would be from lower in orbit to higher energy. If we have to from lower orbit to higher orbit, if we have to take an electron, we'll have to provide energy. Provide energy. Consequently, when the electron comes from higher orbit to lower energy, electron will, Mr. CB, lose energy. This is one thing. Are we clear?
Yeah.
Let us try to understand this from our tree and the man. तो कल कब आ रहा है? एनी टाइम बिटवीन 2:30 to 6. कल आ सकता है, परसों आ सकता है, जब भी है. So, Ms. Avantika, what I'm trying to say is that you are at a lower energy level. So, you are at the ground state. Now, if you have to go to the first branch, I'll have to provide energy. From first branch to second branch, I'll have to provide energy. From second to third, I'll have to provide energy. Is it making sense?
Yeah.
But Mr. Shivang, if I come from third branch to ground state, then I will release energy. Ms. Avantika, am I clear?
Yeah.
So, Ms. Avantika, let us imagine that you are at this branch and something happens, you slip and you come down. So, what will happen when you are coming down?
Loss of energy.
I'm sorry?
Loss of energy.
Lots of energy. So, maybe you will be shouting once you hit the ground, you will maybe fracture a leg or something. Yeah. Maybe you will be shouting. If your friends are there, they'll be shouting. So, the point that I'm trying to make is that whenever we fall from higher energy to lower energy, we have to lose that energy in a certain way. That energy can be in terms of shouting. That energy can be in terms of breaking our legs. But we'll have to lose energy in some way or the other, maybe in heat or light or whatever. Are we clear?
Yeah.
And that is what Mr. Bohr said. कि भाई ऐसा है कि when that electron, Mr. Bohr explained this thing very beautifully. What he said was कि यार, now let us come back to basically fundamentally this is what Mr. Bohr said. Mr. Bohr said, you took that neon gas in that glass apparatus. Then you provided energy to the glass apparatus. Avantika, are we clear?
Yeah.
Now, when those electrons in the neon atoms were provided energy, Mr. CB, what did they do? Higher orbits. And when they fell back to their ground state, they started losing energy. And that lost energy was emitted in terms of, Ms. Avantika, light. Ms. Avantika, is it making sense?
Yeah.
Are we clear?
Yes.
So, this is what Mr. Bohr tried to say in 3 postulates, postulate 1, 2, 4. Now, this third postulate will, at this stage, this will be a bit confusing to you, but it's okay. It is not a problem. So, you remember what is the momentum? What is the definition? What is the formula of momentum? Mass into velocity. Ms. Avantika, am I clear?
Yeah.
Class 9, we had studied P is equal to mv. Do you remember? Now,
Yeah.
this momentum, Avantika, is called the linear momentum. Linear momentum. And when we come to an object which is moving in circles, we have to use something called the angular momentum. Ms. Avantika, are we clear?
Yeah.
We will do this in physics, maybe 4th or 5th chapter. And the formula of angular momentum is mvr. Ms. Avantika, are we clear?
Yeah.
So, where r is the radius of the orbit in which the object is taking turns. Ms. Avantika, are we clear till here?
Yeah.
Very simply, if this is a track of radius r, you have a car which is going around this circle with a velocity v. The velocity on your speedometer is v. Then the angular momentum of this car would be mvr, where m would be the mass of the car. Ms. Avantika, are we clear?
Yeah.
Is it tough? Is it tough till here?
No.
Now, what Mr. Bohr said was he did some calculations. He did some calculations and he said कि बॉस ऐसा है. He did some calculations and said this is a certain radius, this is a certain radius, this is a certain radius. Avantika, are we clear?
Yeah.
And in this is R1, this is R2, this is R3, and in each of the orbits, the electron will have velocities. Are we clear?
Yeah.
बोलो भाई.
जैसे अभी फर्स्ट से सेकंड स्टेप में जाना होगा उतना जो एनर्जी चाहिए वो उतना एनर्जी सेकंड से थर्ड है जब भी जाएंगे उसी तरह के रखेंगे.
Different रहेगा. So what energy? So what Shivang is asking is a good question that he is asking. What he is saying is कि अगर आपको ग्राउंड स्टेट से फर्स्ट ऑर्बिट में जाना, सॉरी फर्स्ट ऑर्बिट से सेकंड ऑर्बिट में जाना है, या सेकंड ऑर्बिट से आपको थर्ड ऑर्बिट में जाना है, या थर्ड से आपको फोर्थ में जाना है, is the same amount of energy required? No, the answer is no. Different amount of energy is required. You'll understand that in a while. Are we clear, Avantika?
Yeah.
Okay. So are we clear with the concept of angular momentum?
Yeah.
So what Mr. Bohr said in his fourth postulate was only those energy levels or energy states are permitted in which angular momentum of an electron is an integral multiple of h by 2 pi, where h is a Planck's constant. Okay, so let us try to understand this. So this pi is the old pi that we know from class 5th, 6th, that pi r square wala pi. Are we clear?
Yeah.
This h is called Planck's constant, and this is some constant. It has some value. Are we clear?
Yeah.
Okay. Now, what Mr. Bohr is saying is कि भाई, if you are in first orbit, you will have momentum equal to h by 2 pi. If you are in second orbit, you will have momentum is equal to 2 into h by 2 pi. If you are in third orbit, you will have momentum is equal to 3 into h by 2 pi. If you are in fourth orbit, you have momentum is equal to 4 into h by 2 pi. Are we clear?
Yeah.
Of course, you can ask a question. उसको कैसे पता चला? भाई बोर है, मिस्टर बोर है. He would have done some calculations. उससे उनको पता चला. Are we clear?
Yeah.
He would have done calculations and he would have arrived at decision कि आप अगर फर्स्ट ऑर्बिट में है, you would have this momentum. अगर आप सेकंड में है, you will have this momentum. And अगर आप इस ऑर्बिट में है, you will have this angular momentum. Are we clear, Avantika?
Yeah.
And I'll keep reminding you, and whenever I forget to remind you, you'll have to remind yourself that Mr. Bohr gave the model for hydrogen atom only. We extended it to rest of the elements, but Mr. Bohr gave it for hydrogen atom only. Are we clear, Avantika?
Yeah.
Is it making sense till now, or is it too much of information shared at one go?
No. It's making sense.
Okay, so these are the 4 postulates, and we should be very clear about these 4 postulates, because based on these postulates, see, we should be very clear about these postulates because this is an independent question which is asked in exams. And the second reason is, so for example, next year in class 12, when we are doing this Bohr model, I will refer you to this model, this particular lecture again. Is it making sense?
Yeah.
Okay. Now, let us look at that 4th postulate again. Now, what he is saying is, कि boss, एक तो he came up with this factor of h by 2 pi, and then there is a second thing that he did. What he said was कि an electron when it falls down, कि हाइड्रोजन का एटम आपने एक्साइट किया, वो अपनी ग्राउंड स्टेट मतलब फर्स्ट ऑर्बिट से सेकंड, थर्ड, फोर्थ, फिफ्थ ऑर्बिट में चला गया. सो taking the electron from lower levels to higher level is known as exciting the electron. Are we clear, Avantika?
Yeah.
So for example, in your class there is this dumb kid. ठीक है? अब some of the smart kids always, they'll do something that this dumb kid does some stupidity, and when the teacher comes, she starts shouting at that dumb kid. Are we clear? You would have these kind of kids in your class. So for example, we used to have this guy, हम उसको उंगली करते थे, तो he would do some dumb thing, some stupid thing, क्योंकि हम उसको उंगली करते थे, and we had identified that he was one of those dumb kids जिसको excite करना बहुत आसान है. तो he'll make a mistake. तो अभी उसको थोड़ा सा हमने हवा किया, तो उसने, let us assume, let us assume teacher के सारे chalk तोड़ दिए. Let us assume. Now when the teacher will come, she will see that chalk box जिसमें सारे के सारे chalks टूटे हुए हैं. So she'll start shouting at that dumb kid. So it was very easy to excite that kid. Is it making sense, Avantika?
Yeah.
So what Mr. Bohr is saying is कि यार ऐसा है कि you'll have to excite an electron to go to its higher orbits. But when those excited electron come back to their ground states or the lower states, they will be releasing energy in the form of light. Are we clear till here? Mr. Avantika, are we clear?
Yes. Yes.
And what Mr. Einstein had told at that time, he had already made the theory. There were practicals, I think, if I'm right, I think experimental readings are also there. So what Mr. Einstein was saying is that light consists of the energy in light consists of photons, and each photon has an energy of h nu. Mr. Avantika, is it making sense?
Yeah.
Let us try to see this again. So again, this is one of the topics that we will study in detail in class 11th. So basically, what Mr. Einstein was saying is that very loosely speaking, Avantika, very loosely speaking, if this is red light, then the energy of the red light is carried by these photons. Photons are basically packets of energy, and each packet of energy is given by a formula E is equal to h nu, where h is the Planck's constant, this is the Planck's constant, and this is the frequency of the color. Are we clear, Avantika?
Yeah.
Let me take another example. So I have a blue light. So blue light consists of photons. Each photon has energy is equal to h nu, where nu is the frequency of blue light. Are we clear?
Yeah.
Red light, h nu, where nu is the frequency of red light. Are we clear?
Yeah.
If there is a green light, each energy consists of that light consists of photons of energy h nu, where nu is the frequency of the green light. Are we clear, Avantika?
Yeah.
So this is what Mr. Bohr is trying to say कि यार ऐसा है कि ये हायर ऑर्बिट से अगर आपका इलेक्ट्रॉन गिरा यहाँ पर या गिरा यहाँ पर, it can come to any level. Are we clear? Maybe you had excited the electron to, let us assume, 6th orbit. अभी वो 6th orbit से let us assume यहाँ गिर रहा है 3rd orbit पे, तो अभी उसको एनर्जी तो रिलीज करनी है, the energy. So basically this is what Mr. Bohr is saying. So for example, let me assume this is the 1st orbit, this is the 2nd orbit, this is the 3rd orbit, this is the 4th orbit, 5th orbit, 6th orbit. So this is my ground state for hydrogen system. Are we clear, Avantika?
Yeah.
So you had an electron here, you provided energy to it. That energy can be in terms of, let us assume, electricity. You provided the electricity to that electron. The electron went to 2nd state, 3rd state, 4th, 5th, 6th, whatever states. Now when it went to that particular state, it absorbed energy. Now when it is coming back, say it is coming back from 4th to 3rd, or it is coming back from 3rd to 1st, or whatever, it will release energy only in terms of h nu. Ms. Avantika, are we clear?
Yeah.
So where h is the Planck's constant, and that frequency is the frequency of the particular actually it will be wrong to say light, it is a particular electromagnetic wave that it is emitting. Are we clear?
Yeah.
Let me make this clear. See, one thing that we need to understand is that when we say light, this light consists of this Vi, B, G, Y, O, R. Are we clear?
Yeah.
Are we clear? And each of these
Yeah.
colors have different frequencies. This is a symbol of frequency. Are we clear, Avantika?
Yeah.
Now, the energy that it will be emitted, when the excited electron comes back would be only in terms of packet of h nu. And let us say that if higher amount of energy is being released, the frequency would be more. And if lower amount of energy is being released, the frequency would be less. Are we clear?
Yeah.
the photon of that particular electromagnetic wave will have lower amount of frequency. Are we clear, Avantika?
Yeah.
Okay. And this is where this particular diagram makes sense. Here you see these electrons falling from, say, 7th level to, from 7th level to, say, 5th level. So here you have from 7th to 5th. Here you have from all the higher levels to 3rd level. Here you have from all the higher levels coming to 1st level. Are we clear?
Yeah.
And they have defined a name that when the electron, excited electron, will fall in the first orbit, it will be called Lyman series. Then in second, it will be called Balmer. Third, it will be called Pasteur. Then bracket. Then P fund. Are we clear? So these are
Yeah.
the names that you will have to remember: Lyman, Balmer, Pasteur, bracket, P fund. Are we clear?
Yeah.
LBP. Are we clear?
Yeah.
So they will give you, when they will give you numericals, they will put the numerical in terms of this Lyman Balmer. So I'll show you a numerical also. So for example, they might have a question like this: spectral line in the Balmer series of hydrogen correspond to find the. So you'll have to know that which one is the Lyman and which is the Balmer. So you should remember the name of these different names. Are we clear, Avantika?
Yeah.
So I think we'll stop the lecture here, and you can go through this again. Basically, I've sent you the scan of these 6 pages that you'll be required to read again. But I'll tell you what happens next. So we are clear with the postulates. Okay. Then what we require is these are the formulas that are given to us, that what is the energy of a electron in a particular orbit. Are we clear, Avantika?
Yeah.
Okay. Then we will be given the radius of a particular orbit. Are we clear?
Yeah.
Then, because we know that energy is released when the shift happens, then this energy change is given in terms of the h nu. Are we clear?
Yeah.
So basically, we will be required to cram formulas of energy, of radius, and the relationship between the energy released and the h nu. Are we clear?
Yeah.
Now, tomorrow when we meet, what I'll do is I'll do few equations with you, basically numericals with you. Are we clear?
Yeah.
So when we meet tomorrow, I'll have these list of formulas with me on one page that you'll have to cram. So 4 formulas would be there that you'll need to cram, and then I will use those numericals, and then I'll use those formulas to do few numericals with you. Are we clear, Avantika?
Yeah.
And if time permits, we'll do that 2 other topics that you had said. Yeah, Mr. Avantika, are we clear?
Yeah.
One is, I think you had said Heisenberg, and the other was the shapes of the orbitals. Yeah,
No, I think I said Hund's.
yeah, Hunt's.
Uh,
I think you
huh.
had. I think you had mentioned the shape of orbitals also. If time permits, we'll do that also.
Okay.
But one thing that you need to understand is, if you don't understand it now, just cram it. That is it.
Yeah.
You don't have
Yeah.
much of an option. You don't have much of an option, at least in class 11th. By the time you reach end of class 12th, many of things will make sense. So, for example, this h nu will make sense. This angular momentum will make sense. Actually, if you look at this lecture, understand what we are. To understand what we are discussing, these are the things that we should be aware of, and these are the things that we slowly learn in class 11th, 12th. Vandika, are we clear?
Yeah.
So let's meet tomorrow and do as many concepts as we can. Yeah.
Yeah.
Okay. Just do me a small favor. This PDF that I have sent, just read through this portion only. These 6 pages only. I think by tomorrow things will start making sense to you. And if you are interested, you can go through this lecture again if you are interested. Yeah.
Yeah.
Okay. I'm stopping the meeting. Yeah. Avantika, I'm ending the meeting.
Yes.